All right, so first off, what we want to do is recall what a power series looks like, okay? So let me put that right here. Recall a power series centered at 0. Okay, so a power series centered at 0. This is what it's supposed to look like. The sum as n goes from, let's say, 0 to infinity of a sub n x to the n, which if we kind of expand a little bit, it's a sub 0 plus a sub 1 x sub 1. X to the first. Or I guess we don't have to write the first. Plus a sub 2 x squared plus a sub 3 x cubed, etc., plus a sub n x to the n, and then etc. past that. Okay, so we do have that definition that we actually used before. Let me look really quick. Power series was section 9.8. Okay, so that was the one that you guys did take a quiz on before you left. But that was something we learned in section 9.8. Okay. Also, we want to recall the sum of a geometric series. So the sum of a geometric series okay, and the sum of a geometric series is given to us like this. It's a times r to the n, which was defined as a over 1 minus r, as long as the absolute value of r was less than 1. So that's how you would find the sum of a geometric series. If you knew something was a geometric series, all you have to do was identify your a and your r value, plug it into a over 1 minus r, and it would tell you what that geometric series would add up to. Okay, so these are things that we've done before. Okay, so knowing those two things, okay, knowing what a power series looks like, knowing what the sum of a geometric power series looks like, then we're going to be able to write power series for things that look like this. So let me give you an idea of what we're doing here. So we should be able to write a power series representation let me put right here, for f of x equal to 1 over 1 minus x. And we'll center it at 0. Okay, so knowing those two things, we should be able to do it. Now you might say, well, I don't see how to connect it. Well, let's just kind of look at the information that's given to us. Okay? So if we know those two things, what a power series is supposed to look like and what a geometric series looks like, you notice they kind of look the same, right? The main definitions, a times r to the n, a sub n x to the n, right? In the main definitions are very similar. So what they want us to do is get a function and see if we can kind of make it look like a geometric power series. So a over 1 minus r. Now if you notice, a over 1 minus r and 1 over 1 minus x look similar, right? So note that 1 over 1 minus x and a over 1 minus r look similar, right? So we're going to let a equal to 1 and r equal to x. Right, so I just see that they're the same. They're written out the same. There's a subtraction on the bottom. It's right. They kind of look like the same type of fraction. I'm just going to let some substitution occur and let a equal to 1 and r equal to x. So if I do that, then 1 over 1 minus x can be represented as the following. Now I'm going to rewrite it as a geometric series. Remember, it's a times r to the n, right? A times r to the n. I'll actually write it down here. That way you guys can see. If you're looking at your notes later, you can actually see it. A is 1, r is x to the n. So the geometric power series is basically the sum as n goes from 0 to infinity of x to the n. That's what 1 over 1 minus x would look like if you rewrite it as a geometric power series. So the trick to doing these problems, most of the students, whenever I teach them this stuff, at first they're like, this just looks kind of weird. But, by the way, I probably should note, I'm going to put note, the absolute value of x should be less than 1, right? Because that's my r value, right? So whatever x happens to be, the absolute value should be less than 1. A lot of students will look at it and say, okay, this isn't so bad. It's a little tricky at times to rewrite my equation, but once I figure it out, writing up the power series isn't that difficult. So this is an easy one, right? It's kind of set up for us perfectly. So let's try doing one that's not set up for us so perfectly. Okay, so let me see. Did I miss something here? Hold on, give me a second. I want you guys to notice that if this power series is to exist, what would be its radius of convergence? Look at what I wrote right there. No absolute value of x must be less than 1. What's its radius of convergence? The r value. A 1, right? It's just a 1 because it's right here, right? This right here is my r. What's my interval of convergence then, since it's centered at 0? -1 to 1. Open intervals, and then from there you would have to test it, right? You would test -1 to see if it works. You would test +1 to see if it works. If it does, then you can, kind of like refine your interval of convergence. But remember, your r value is there. Okay, that's how you figure it out. You just basically get your definition for r, which was x, put it in an absolute value, and you put less than 1. Now, anyway, it's just something for us to look like. Now, what if we did the same thing here? Same idea. Did I write it in blue? Yeah. So let's get the same idea, but let's change its center. So let's write f of x equal to 1 over 1 minus x as a power series centered at, we'll do it at -1. Now remember, this piece right here, that's where your center comes into play, right? You can tell that the absolute value of x, right, it's centered at 0 because it's x minus 0. There's nothing there. But in this case that I have coming up, I want it centered at -1. Okay? This problem here is centered at 0. So I can't just say, oh, my answer is the same. Right? It's just the sum as n goes from 0 to infinity of x to the n. Well, I can't, because it should say x plus 1, to the nth power. Right? Because it's centered at -1. So I have to go ahead and figure out how to manipulate this problem. Now, this is where it gets a little tricky, but like I said, still a lot of people don't think it's super difficult. They just say, okay, I got to manipulate some stuff. So here's the thing. When I'm doing this, I have to figure out a way to rewrite 1 over 1 minus x so that it shows that it's centered at negative 1. Now, if I want it to be centered at negative 1, then this last part on the bottom should say that, x plus 1. Okay? Now, it has to have a minus in the bottom. So I'm going to put a minus right there. What number should I put in front of that minus so that when I simplify the bottom, it still equals to 1 minus x? Well, if I put a 0, then if I simplify this, this becomes negative x minus 1, which is not that. I should put a 2. Okay? Because 2 minus x minus 1 is the same as 1 minus x. Does that make sense to you guys? Okay, if I get 2 minus x plus 1, that's 2 minus x minus 1, which is 1 minus x, which is exactly what I want it to be on the bottom. I want it to simplify to 1 minus x again. Now, the reason why all this stuff happened is because of the fact that I needed this piece here to show the center portion, centered at negative 1. Now that I have that, to top, well, the top's kind of easy. I'll just put a 1. Okay? Now, here's the deal. Notice how in this problem, there must be a 1 in that position. Now, for me, it's a 2. But there must be a 1. Okay, that's kind of like the rule of this thing with geometric power series, that you must have a 1 and a minus. Like, that must be true for anything that you build. There must be a 1 and a minus. I have the minus there, but I don't have a 1, I have a 2. How do I make that 2 into a 1? I can simplify, but if I do, then I'm back to where I started. Right? I want to keep it so it says x plus 1 there. So how can I get rid of a 2? What's the easiest way to get rid of a 2 to make it into a 1? Well, if I multiply by 2, I make it a 4. By a half, or divide everything by 2. Right? I can divide everything by 2. So, the top will become a half. Okay, the bottom will become a 1 minus x plus 1 over 2. Everything got divided by 2. Okay, so 1 became 1 over 2. The 2 became a 1, because 2 over 2. And the x plus 1 just becomes an x plus 1 over 2. Now, what I have right here is exactly what I need. Okay, I know that I'm going to let a equal to half, right? A is equal to half, because my a is supposed to be the top number. And my r is equal to x plus 1 over 2. Now remember, my r value should be less than 1. Well, the absolute value of r should be less than 1 because we're using geometric series for this, right? So that means that the absolute value of x plus 1 over 2 must be less than 1. Don't forget that. And the reason why I tell you that is because if they were to ask you, what is the radius of convergence, and you say 1, then you're going to get it wrong. What is my radius of convergence? It's a 2, right? Because it should be half of x plus 1 less than 1, or absolute value of x plus 1 less than 2. Right? My radius of convergence is a 2. My interval of convergence, well, since I'm centered at negative 1, it should be from negative 3 to 1. open-ended. And then if you want to figure out, does it work on the endpoints, then you got to test it. Okay? But this is just extra work, okay? This is just extra. If you needed to do it. Let's continue with this problem. If they want me to write a power series using this information, then my power series will look like this. 1 over 1 minus, or not 1 over 1 minus x, but my half over 1 minus x plus 1 over 2 would look like this. The sum as n goes from 0 to infinity. I'm going to write the a times r to the n again, just as a reference, okay? My a value is a half, and my r value is an x plus 1 over 2 to the n. Now, there's a common mistake that occurs. People stop here and they say, I'm done. Okay, I found exactly what they wanted me to find. But there's a quick problem that's happening here. If you look at your definition for the geometric sum, okay? So if you look at, where is it at? Up here. Okay? There's never supposed to be a fraction there. It's just supposed to be an x minus c. You guys remember how like the Taylor series was? It was always like a sub 1 times x minus c to the first, and a sub 2 x minus c to the second over 2 factorial, etc. But it was always just x minus c. It was not like x minus c over a or anything like that. There's no fractions in there. So what we have to do is factor out that 2 on the bottom of the x plus 1. Well, if I do that, it's not a hard thing to do. I'm going to have half 1 half to the n x plus 1 to the n. Now I'm doing this step by step, by the way. I could do this a lot faster, but I want you guys to see the process of it, okay? Now, half to the n is the same as 1 half times 1 over 2 to the n times x plus 1 to the n. What's 2? Look at the denominators. What's 2 times 2 to the n? Yeah, it's 2 to the n plus 1 times x plus 1 to the n. And that is your geometric power series. Remember, no fractions, okay? So you're going to have to work them out. So notice you can easily tell that you are centered at -1 because it says x plus 1 to the n, right? And it's 1 over 2 to the n plus 1. Now people say, well, wait a minute, Mr. B, the geometric sum does not have any n's in it. I can prove it to you. Look right here. It's just a constant a. Well, yeah, geometric sum does not have any n's in it, but we are doing geometric power series. And in geometric power series, there could be n terms in it. Right? A sub n, not just a. So it's okay to have nth terms in your constant that we write in the front, okay? Because it will be changing. So that's fine. We're just using the geometric sum as a guide. And then from there, we rewrite it as our power series. So let me show you another one of these things. This is actually what I'm about to do is actually example 1. The other two are just kind of me walking you through some of these things, how they look. So I am going to write example 1 for this one. The other two are examples, but just kind of like, hey, here's what happens if this were to occur. Here's what happens if that were to occur. So let's find a power series. For f of x equal to 4 over x plus 2, centered at 0. So we'll start off a little bit on the easier side. Centered at 0. Now, you'll notice they don't say to write a geometric power series. Okay, they don't tell us that. But you're supposed to be able to say, oh, wait a minute. That looks like a geometric sum. So maybe I got to use a geometric power series. Okay? So that's up to you to kind of see it and say, okay, that is a fraction. It looks like a geometric sum, so maybe I got to use geometric power series. All right. So just like with the other stuff, I start with what's given. And I have to make it look like a over 1 minus r. Well, the a part could be a 4. I mean, there's nothing wrong with that. Then it's supposed to say 1 minus r. So your x value should be on the right side. So let me change that. 2 plus x. But I'm supposed to have 1 minus. So let me manipulate this just a little bit. 4 over 2 minus. If I put a minus there, what do I do with my x? It becomes negative. So that means I'm going to put minus x. Yeah, hold on, let me fix that. So, I thought you wanted to do 1 minus x. No, I know, we're not done yet, but we're almost there. Think about it. If you're thinking like, wait a minute, but why is the x negative? We will eventually make it an absolute and stuff like that. So eventually we can remove stuff that we don't need. But the key is to have a 1 minus, right? Now I have a 2 there, so we're going to do the same thing we did last time. Let's divide it out. So let's divide by 2. That's going to give me a 2 over 1 minus negative x. Okay? So what's my a value? And what's my r value? Oh, yes. Close your eyes. There it is. So yeah, negative x over 2. Thank you. I was going to write that, but I didn't write it on the other one. Sorry about that. It should be, let me write it out nicely. It should be a negative x over 2. Because of division by 2 all the way throughout. Okay. Now, what I'm about to show you again is just extra. Let me change the color to green here. If they wanted to know what your radius of convergence is, you'd write negative x over 2, right? You can take out your negative 1, but when you take it out, it becomes this. The absolute value of negative 1, which is 1. And then you take out your half, which would be the absolute value of half, so it's just half. And that would have to be less than 1, so that means that your radius of convergence is 2. Your center is 0, as you can see, and your interval of convergence would be from negative 2 to 2, right? And then, of course, you can test if you needed to. Again, this is just extra, but just kind of showing you this because there will maybe be questions like that on the AP exam, whether you're going to have to write this out, and they're going to want the radius of convergence, what's your interval of convergence, your testing, all that stuff. So that's how you would go about figuring that stuff out, using the information you're given. Okay? So now that we have that, we know that, I was using red, right? Yeah. So we know that our a is 2, our r is negative x over 2. So what I'm going to do right now is I'm going to write it out the way they want us to. So 4 over x plus 2 is equal to the sum as n goes from 0 to infinity. And I'm going to, well, I'll write my kind of generalized thing there. You don't have to write that a times r to the n. I'm just putting it so you guys can see it. Our a is 2. R to the n, that's negative x over 2 to the n. Again, I'm going to take this slowly, just breaking things down little by little. That way you don't feel like you get lost with the work we have. Let's start taking things out that we don't need. So the sum as n goes from 0 to infinity of 2. I'm going to factor out a negative 1 to the n and a 1/2 to the n from that. Do you guys see that? Because there's a negative 1 inside of the negative x over 2, and it is raised to the nth power. So I'm going to take it out, negative 1 to the n. And then there's also a 2 to the nth power in the denominator. So that's the same as a 1/2 to the nth power, right? So I'm going to take that out as well. Now let's keep simplifying. This is 2 times 1 over 2 to the n times negative 1 to the n x to the n. Now let's just do a little bit of scratch work here. 2 times 1 over 2 to the n is the same as 2 over 2 to the n, which if you simplify, this is a 1, right? So that would be 2 to the 1 minus n, right? So that's 2 to the 1 minus n. So let's write that out. This is the sum as n goes from 0 to infinity of 2 to the 1 minus n. Actually, if you guys wouldn't mind, I'm going to put the negative 1 to the n in the front, okay? Since usually we like to see our alternating thing to be kind of obvious. So let's put it in the very front. And then 2 to the 1 minus n times x to the n. And that's our geometric power series for that one. Of course, if they ask you, does this converge, then you'd have to do an alternating series test, stuff like that. But that's how you'd write it out. Now remember, if you leave it like this right here, it's not that you're completely incorrect. I mean, you do have everything that's needed. You have the A, you have the R, right? It's there, but it's just not in the right format. So you got to make sure you make it so that it's obvious, right? That this part right here shows you that it's centered at 0, right? Not x over 3, not x plus 5 over 7 or anything like that. You got to make sure it's an obvious tell that you're getting the center by just looking at it. Okay, so nothing wrong with the one that I put a big arrow on at first. It's just, it's not in the right format. So they could mark you off. Okay, so that's us just kind of messing around with what's given, making sure that it looks like it's in the right format for us. Now, we'll do one more, and let me see. Actually, I was going to check here. We get out of here at 10:31. Let's see, we should be able to do this one pretty quickly, I hope. Okay, and then I'll stop. So this is going to be example 2, right? So example number 2. Even though we've done now what's going to look like 4. So find a power series. And we'll work on this one a little faster. For f of x equal to 1 over x centered at 1. Okay, centered at 1. So I want to show this 1 over x, but centered at 1. Now, if it's going to be centered at 1, it should say x minus 1, correct? So it should say x minus 1. Okay. So if it should say x minus 1, and it's supposed to be a minus here, okay, what number should I put on the other side to make it so it's just an x? A negative 1. Right? So negative 1. So negative 1, then minus x minus 1. Okay, on top, we'll just put a 1. Now, if I simplify the bottom, negative 1 minus x plus 1, you guys notice anything kind of weird with that? Does that simplify? Negative 1 minus x minus 1, does that equal to x? It's negative x. So something's off. What can I do? If I want that x to be positive, then what must I do to that x? Make it negative. But if I make it negative, that means I applied a negative to that parenthesis, right? So what would happen to that minus 1 after it? This would become a plus. So now all of a sudden that minus 1 can't be a minus 1 anymore because it wouldn't make sense. What is it going to be now? A positive 1. Okay, so even though we were correct at first, picking the right numbers to put in, you always have to simplify your denominator to ensure that it matches your other denominator. Because if I would have never done that check, then I would have never known that I was wrong. Okay, but what we have there now, that is correct. Okay, I'll rewrite it right here. 1 over 1 minus negative x plus 1. Now, if you look at it, you're like, wait a minute, but that's not centered at 1 because it says plus 1. But it actually is, right? Because the x is negative, right? So it is in the right place. And you'll see at the very end, it'll be proven to you that we have it correct. So let's go ahead and write down, we're going to let a equal to 1 and r is negative x plus 1. Remember, if you want to prove that your radius of convergence, you just set your here's some extra work. You're going to say your absolute value negative x plus 1 less than 1. I'm going to factor out a negative 1. So negative 1 in the absolute value, that leaves me with x minus 1 less than 1, which is basically the absolute value of x minus 1 less than 1. And now you can see that is centered at 1. Right? So we have done it right, even though it doesn't look like we did it right, but if I simplify it, it's correct. Okay, it is centered at 1. Now let's go ahead and finish up this problem here. 1 over x is the same as the sum as n goes from 0 to infinity of a r to the n. Again, I'm just writing that for reference. A is 1. And r is negative x plus 1 to the n. But I cannot have a negative x. So that means I got to factor out the negative 1. So this now looks like this. Negative 1 to the n times x minus 1 to the n. And I'm good. At this point, I'm good because it does have an x minus c look to it, right? X minus 1 to the n. So I am centered at 1. I do have my a sub n, which happens to be negative 1 to the n. But it is there. So everything's good. So I'm just going to write that as my solution. And remember, if they ever say, like, what are your restrictions? Then you would say that my restriction is as long as this is less than 1. Okay, that would be your restriction. That's why I show it to you guys, your radius of convergence. If they say, like, well, where does this converge? Well, you say in between there. Or you can be more specific and say, well, I'm centered at 1 with the radius of 1, so it's from 0 to 2. And then, of course, you got to test your endpoints. Okay, so we'll stop right there. We'll finish tomorrow.